This conference will now be recorded.
Okay, so guys, we covered classification. Now I'll go with regression predictive scenario. See, as I very clearly mentioned, right, if your outcome is binomial, yes or no, so we go for classification. If your outcome is continuous, if it is a number or an integer, we go for regression predictive scenario. Okay, so generally regression is the most commonly used predictive scenarios because it's used everywhere, guys. Like you want to do some kind of a sales predictions or revenue predictions, expense predictions. Okay, you want to predict your marketing trends. Okay, you want to do some weather forecasting, you want to do some inventory predictive or inventory forecasts. So for everything we make use of regressions only. Okay, that's the most commonly used predictive scenario. Okay, so this is all classification. So so generally so mesh allows predict continuous means if your outcome is number or integer, outcome variable y based on one or more multiple predictor variables, right? Predictor variables are denoted with x, outcome variable is with y. There can be multiple predictor variables. So generally what happens in regression model is regression model actually builds a mathematical equation. It actually builds a mathematical equation, guys, that defines y as a function of x variables. Okay, and then that equation is used to predict your outs. Means like you just feed the x values to that equation, it will generate the y value. A simple example I give you. So suppose here, guys, you have advertisement cost as x and sales as y. Means you want to predict the sales for the 6th year. You got 5 years historical data. So based on this, so it will actually create a mathematical equation, guys. Here I can put something like y is equals to 10x plus 100 for suppose. X is advertisement. So 900 plus 100,000, it's satisfying, right? Few values, see, it doesn't mean all values should satisfy that equation. Okay, so there might be here and there deviations, that's fine. Okay, so for suppose it generated, based on this data, it generated a mathematical equation called y is equals to 10x plus 100. So then if you feed x value to that, okay, so 200, so it will predict your sales as 2100. Simple. Okay, so it always generates. So in regression predictive model, guys, so your algorithms will work on the data and they generate a mathematical equation based on the data. Okay, so then in the next scenarios, if you feed the x values, it will fit that x values into that mathematical equation and predict your y value based on the mathematical equation. That is how your basic regression works. Okay, so it is used in prediction, forecasting, time series, weather conditions, sales predictions, marketing trends, everywhere, wherever you go, you see regression, guys. Okay, sales, inventory, expense management, wherever you want to predict something, we make use of regression. Okay, as you all know, so dependent variable, independent, these factors, right? So your outcome variable is dependent variable, or your target variable is dependent variable. Your predictor variables are called independent variables. Okay, you already know the multicollinearity, right? If two or more variables highly related to each other exhibit similar influence on your target, such condition is multicollinearity. It should be avoided in your predictive model. Outlier, guys. Generally, you don't make use of outliers in classification, but in regression we see outliers. Outlier is like a too high or very low value, guys. Okay, outlier is something which is very high or very low value. So it generally outliers will impact your predictive outcomes. So they should be avoided while creating a predictive model. I'll give a simple example. Suppose, guys, in 2020, due to COVID situation, your company posted very low sales for a couple of months. Okay, if you just feed it, consider those values also. What happens? It will consider the low values, means it says that okay, your company is in declining trend, and it will predict very low numbers. So they should be avoided. Okay, because they are like uh, what do we say, out of blue situations, and generally those very low values or very high values should be avoided while creating a predictive model. Imagine guys, for suppose my company, I take an example of Apple. Guys, Apple on the launch day, they sell very heavily. They sell the products very heavily, right? So every year they have a launch of new product, right? If they consider that very high value for day-to-day prediction, so even the next day predictions will be on very higher side, right? Which is not the deal. So that's a one-time activity. That's like a one-time value. Okay. So generally these very high or very low values should be avoided while creating a predictive model. System generally avoids that SAC. Machine learning will identify the outlier and avoid the outlier. If ML algorithm is not avoiding, so then we need to manually make sure that high or low values is avoided in the uh, data feed. System will identify here, not even a hurry. And make sure your models are not overfitting and underfitting. Overfitting or underfitting means if you go with very less historical data, that's an underfitting model. If you go with too much historical data, that's an overfitting model. Okay. So for suppose guys, you given last 6 months data, and imagine your company is a seasonal company. For suppose your organization is some kind of an airlines or travel related organization, guys. They post good numbers in Q4 season, but you feed only 6 months data, Q1 and Q2. So there is no Q4 in the historical data. So system doesn't know the seasonality, right? So don't give very less amount of historical data which doesn't cover all the data points. Second, don't give 10 years or 7 years or 5 years of historical data, because guys, the business case scenario before 10 years is completely different from how the company is running now, right? It is always ideal to use the last 3 years or 4 years of historical data. Don't go beyond it. That is what we say to the people. If you're predicting for next 1 year, ideally is go for 4 years. Means your historical data should be means your prediction time frame should be 25% of your historical data. Okay, so 3 years, 4 years is ideal. Don't go beyond that. If you're predicting for next 1 year, if you're predicting for next 1 or 6 months, go for 2 years or 3 years of historical data. That is fine. Okay, so make sure we don't give too much historical data, or we don't give very less historical data to our predictive model. Okay, so these are the things that should be present. So this is fine, right? So this is my use case, guys. So I'm gonna predict the claim amount the customer is going to make in a motor insurance company. So you can read this out. So take a minute or so and just read this out. I'm going to implement this predict motor insurance claim amounts. So guys, this is the standard SAP case. I'm using the standard SAP data here. Okay, not my own business cases. Okay, guys, take a minute. Just read this out. I'm going to execute this scenario today as part of regression predictive analytics. Okay, so here you go. So generally, guys, so I'm going with the motor insurance company. Guys, right now the motor insurance changing its dynamics, right? So right now they're going for auto approvals, right? Without much inspection on the what do you say, on the damages. So so what happens is generally, so we're going to make use of a regression predictive model to predict how much the customer is going to claim for the next year or whatever it is, for the next year or for the next financial or calendar year, how much the product customer is going to claim. So we're going to predict that amount. If that claim is in that range, so they will auto go for an auto approval, which will improve the customer satisfaction and customer will renew this product. If that is very high value than the predicted claim amount, then they go for an inspection on that product. So that is what the main agenda here. Okay, so here you see it's after digitalization they are becoming very much claim friendly. So here you see goals of my claim settlement department are improve customer satisfaction by expediting the claim process. How do they improve it? So if the claim amount is within the range of the predicted amount, so they will immediately approve, improving the customer satisfaction. Reduce the chance of false claims. So they want the smart predict scenario to identify which customers might make false claims. So here you see, so the predictive model will identify which customers might go for a false claim. Generally, guys, in Western world, especially a lot of non-employed people make some false claims. Okay, they have some issue, they just make a fake accident and go for the false claims. And any heavy amount must be scrutinized. So how do we do that? Based on our predicted amount. So my agenda is to predict the claim amount of the customer. So based on that, the claim department will settle the claims. If it is within the range, they will auto settle it. If it is very much above the range, they'll go for an inspection. And also they will check with for the customers who might have a high chance of making a false claims. Right. So this is the basic agenda of my claim settlement department, and our agenda is to understand claim amount per customer which is expected to come, claim amount pattern with respect to vehicle segment, and check for false claim. This is the objectives of our smart predict scenario. Okay, let's go with the data. Let me show you the data so that we can implement this data. Okay, we can implement the regression predictive model on top of this data. Here you go. So this is your data. You see all the customer information is customer state, customer lifetime value, then coverage of the customer, what type of coverage he is in, education of the customer, effective date, employment status of the customer. These are all customer details, gender of the customer income, and customer location, customer marital status, all the customer details. Then you see premium details, the insurance details, monthly premium, months since last claim, months since policy inception, number of open complaints, number of policies, policy type, policy renewal, sales channels. You see all the policy details, the total claim amount made by the customer historically, vehicle class and vehicle. We see three details here, guys. Customer details, all customer details like customer education, customer employment, customer marital status, customer location, okay, state, everything. Then you see policy details, okay, the policy type, policy number of policies had, policies months since last claim happened. Then you see the claim amounts, okay, and also you see the vehicle details of that customer. So I'm going to make use of this data, historical data, to create a predictive model. Okay, we got around 8,000 records. I'm going to use this data. 8,000 records is a fair volume of data, I can say. And then this is my current data set. So this is, here you see the current customer details. And now we're going to predict the claim amount of this customer on the current data set. Okay, right. So first, step one, so guys, for classification regression, we follow the same four steps. For classification regression. The process is same. Create data sets on your historical and current data by importing data from files. Okay. Now let's go more. Create a data set. Take data from file. So I see customer lifetime value is a measure, income measure, monthly premium measure. These all are measures, fine. These all are dimensions. These all are okay, fine. So I don't have any changes to make here. So I just save it up. I save this data set. I'll create another data set now on the current data. Okay, so we're done with step one. So we created data sets, couple of data sets on historical and current data. You see, two data sets were created. Now step two, guys, let's create a predictive model on top of your historical data set. I go to predictive scenario. So this time I would like to predict the claim amount. So I'll go for regression predictive scenario. I go train my data source. I train my data source with the historical data. Check your column details. Guys, here I would like to predict the claim amount, right? Let's check the claim amount. It should be number or integer and it should be continuous. Yes, fine, no props. So here I go to the target, make my total claim amount as a target. I would like to predict the total claim amount. So remaining all will become predictor variables by default. You want to exclude any influences, you can exclude it. This customer ID has got no influence on your claim amounts, right? So if customer ID is 100, it won't influence, right? If it is 200 less claims, customer lifetime value will have influence. Income of the customer might influence. Monthly premium, the biggest influencer of your claim amount. So more the premium you pay, more will be the claims. Month since last claim, I think it will impact. Month since policy inception. Number of open complaints don't impact your claim amounts. Okay, number of policies will impact. Total amount is fine. State might impact, guys, because maybe we might see more claims in one state, particular state. Response is yes or no, it won't impact your claim amount. Coverage obviously impacts. If it is a premium coverage, we can go for high claims. Education of the customer. So this is majorly used to check the false claims. Okay, I'll take it. Then effective date has got no impact on claim amount. Employment status influences your claim amount, guys. Okay, so there might be high chance that we have a high claims when employee is unemployed. But one thing I can see here is, guys, income and employment status are directly related. Income and employment status are directly related to each other, right? They're straight away related. So in this case, you need to, this is kind of a multicollinearity. You need to exclude at least one. I'll exclude income. I'll go for employment status. I can exclude education also if needed. Because I'm going with employment status, I can exclude them. So far I excluded 6. Gender, I don't think influences, but I'll take it. Location code might influence because we might have more claims in urban or suburban regions. In rural, you'll have less claims, right? Marital status, I don't think will influence. Or okay, let's take it. Maybe unmarried people might go for high claims. Policy type and policy will obviously influence your claims. How he is renewing, right? So renewal has got nothing to do, or how he purchased the policy has got nothing to do with the claims, right? Vehicle class and vehicle size obviously influences your claim. I excluded 8 columns from the list. Customer ID will not influence. Income I excluded because I got employment status. Number of open complaints. Response is yes or no. It also doesn't impact your claim process. Education I excluded because I got employment status. Effective date. Renewal offer and sales channel. How he purchased the policy rate has got nothing to do with the claims. As I select, so I excluded 8. So let's say train your predictive model. Oh my god. So here you can see I got a predictive model with around 99.14 prediction confidence. This is very high. And I got a predictive model with the root mean square error. This is like an error component of 119. Okay, so how do we calculate root mean square error? This is the formula to calculate root mean square errors. Okay. So generally, if root mean square error is less than 10% of your range, then it's a good model. If it is less than 5%, it is even sophisticated. In my case, my range, if you see my range, guys, it is from 0 to 2800, means almost like 3000. 10% is 300, 5% is 150. So in my case, it's 120, it's almost 4%. Your error percentage is 4% here, which is very, very sophisticated. I can say very good model this is. Okay, a near perfect model. Check your RMSE, check the range of your data, check your mean value. Okay, or your standard deviation. So if it is less than your mean or standard deviation, it is very good. Here it is half of that, right? So maximum check your range of the data. So my range is 2900, almost 0 to 2. Maximum minus minimum is your range. If it is less than 5% of your range, it is sophisticated. If it's less than 10%, it is good. In my case, it's only 4%. So you see, in training dataset, your minimum value is 0.1, maximum is 2893, mean is 432, standard deviation is 287. In validation dataset, as you clearly know, right, the historical dataset will be split into training and validation. 80% of the data goes for training and 20% of the data goes for validation purpose. Around, not exactly. Okay. So you see how different factors influence your uh, claim amount. So you see, green line is a perfect model, blue line is your validation curve. Almost your blue line matches with your green line, right? It's a near perfect model almost. And you want to see how different factors influence your outcome. So the biggest influencer is location code, followed by monthly premium, followed by employment status, marital status, and vehicle size. These are the top 5 factors influencing your predictive claims. You want to see how location code influencing your predicted claim amount. Guys, you see we got 63% of the customers in suburban region, and with the average claim amount is 555 here. Whereas in urban it's only 320 average amount. Rural we got 19% of the customers and average is only 111. So we should focus more on the customers from rural region. Then you see monthly premium increases, guys. Obviously predicted claim amount also increases. Fine, you can know. You want to see the marital status. In case of single, guys, the average claim amount is 537, 26% customers. Okay. In case of married, it is only 390, 60% customers. Vehicle size, you see. It is small vehicle. Okay. So average is 479. If it is a mid size and large vehicle, 417 only. Small vehicles has high claim amount. Because they, okay. Then you see employment status. Unemployed has the high claims. There might be some false claims happening. There is employed has 362, unemployed average claim is 587. This is how you see different factors influencing your claims. Okay, so we're done with step 2. We created a predictive model on the historical data set. Okay, so this data set will be split into training and validation data set. So this training data is exposed to all the algorithms. These all algorithms will work on the data, create their own predictive models, right? That means they create their own mathematical equation that will be validated and the best fitting model will be given as outcome. Okay, so I got the outcomes now. Fine. Predict. Now let's apply this predictive scenario on top of it on your current data. So I'm going with step 3 now. Predictive model is created. Now let's say apply predictive model on current data set to get the predictive outcome. Let's apply here. I'm applying this on current data set. Okay, what columns you need in the current data set? I want customer, guys, because I would like to report on the customer. You want whatever you want, you can pick it up. Customer income, monthly premium customer is paying, month since last claim, month since policy inception, number of policies the customer has, state of the customer, coverage of the customer, employment status, gender, location code, marital status, policy type, policy, vehicle class and vehicles. So I just selected 16 columns, what I need in my outcome. And in the statistics and predictions, I would like to see on what date it was applied. I don't need an assigned bin. Assigned bin is majorly for classification predictive model. Here I'll go for outlier indicator. Is there any outliers in the data? Predicted value, here it will predict your claim amount. Okay, prediction explanation gives you why it predicted. So that's fine. I don't want explanations. So I've taken 3 columns here. So total 16 plus 3, 19 columns. It will create a new data set at 19 columns. Okay. Okay, your replicated column statistics and predictions, and it will generate as a predicted data set. Let's say apply. Guys, you can actually create a multiple predictive models, guys. Here you see, you can actually create multiple predictive models by changing your variables. Okay, so suppose here I think marital status and employment are related to each other, or I don't, okay, I don't want to see the marital status. In this case, what I do, I can create a new predictive model here, or I can do something like duplicate. I duplicate this. Here I'll try to influence by excluding marital status here. Okay, I exclude this also. Let's retrain. Oh my god, I'm training the first model again, guys. I'm sorry. I didn't select the second model. I'm sorry. Okay. So first model I'll remove. Sorry, I'm sorry. I just need to change it in second model. Let's retrain. So we can create multiple models. So you see 1999. So I go to model 2 now. So you can have multiple models by changing some influences. You can create multiple models and pick the model which is right for you. Let's see. Now second model is getting trained. See, prediction confidence 99.3% better prediction confidence, but RMSE was higher in model 2. So I'll go with model 1 only. Okay. Like this, you can create multiple predictive models. So I have now, we applied the predictive model on the current data set to get the predictive data set, guys. So here you see we got a predicted data set also created. If you open the predicted data set, see customer ID, income of the customer, monthly premium, month since policy inception, number of policy, state, coverage, employment status, gender, location, marital status, policy type, all the details. And here you see predicted value. So here I'll rename this as predicted value. I'll rename it as predicted claim amount. Is applied it on what date this has been applied, and there are any outlier indicators. Let's check outlier indicator. Change outlier indicator to a dimension. They don't have any data. So it's all null. So like in this case, what I do, I go delete this column. As there are no indicators, I'm deleting it. Fine. So I have all my data in the predicted data set. So I have my so we applied the predicted model on the current data set, and we predicted the claim amount for each and every customer which is going to come. Now what we need to do, so we need to showcase it to the claims department, right? How we showcase this data in form of a beautiful story. Now the step 4, let's create a story on top of your predicted data set. Okay. So as I very clearly mentioned, is even though you have strong understanding on machine learning, you don't even know what was the algorithm working in the background. I don't know, seriously, what algorithm was getting applied on the background. Okay. So clear, guys. Any questions, anyone so far?
It's not a question, Satya, just a clarification. When I'm trying to log in, it's not allowing me. Would you suggest anything on that?
Mm, Is it expired? Try to recreate a user.
It's, it says authentication is something wrong. Yeah, but even though it's the same user ID and password, it's only like I'm facing this issue from today, actually.
Try. I think your user got expired. Sridhar. Try. So what you need to do is very simple. So go to your session 2. You remember, right, on session 2. No need to register at sap.com. Once again, you already registered, right?
Mm.
Just go to your SAC, click on Experience SAP Analytics. So it will try to recreate another GE user for you. No need to log in, just recreate the step one. Just log in with sap.com. Go to SAP Analytics Cloud. Click on Experience Analytics Cloud. It will generate another GE user if it got expired.
In that case, whatever we created in the past, that won't carry forward to this, right? It's already it's fresh, right? It's new one, right? Satya?
Yes, yes, it cannot carry forward. What you need to do is, guys, generally we suggest one thing. When you create a user, okay, maybe after 15 days or 20 days, create another user. Share it across. If this gets expired, that user will be useful. Then create another user, share it across. So when your user is working, just try to create another user and share it with your users, other users.
You said some cheat codes we can apply. Can you, if possible, you can give that?
Yeah, I need to go to the planning to apply the cheat codes. We need to run some jobs that will be done in the planning. You need to wait for the planning.
Okay. Okay.
You
Same
can
mail
So
ID.
understand.
that
So that
Same mail.
also sometimes works, sometimes doesn't work. Okay. So if job is running, the user doesn't get expired very quickly. So for the job to run, I need to go to the planning.
okay, Satya. So before it expires, we need to create one more, and we have to carry forward all these to that one.
Create another user, just carry forward and then just share it across. That's it.
But with the same mail ID, it will be given because our SAP ID is same, right? One only, right?
See if SAP ID with only one user will run, right? So try having two SAP IDs, two email IDs registered. So you can change the users within these two.
Okay. Okay.
Right. So I have my predicted data set ready. Now I'll use this to create a story on top of this. Okay, guys, just give me a moment, please. So I'll be back in a minute and I'll start working on the story on top of this data set. Okay, so guys, now I would like to do some reporting on top of this predicted data set. So for that, I have a monthly premium, but I would like to see the premium paid. Uh, Okay, I cannot create any new calculations here, guys. Yeah, in datasets, see in datasets we cannot create any new calculation. So what I do is in this case, I need some calculations. So what I'll do, I'll build a data model on top of the dataset and then build a story on top of it. In the classification, I build a story directly on the dataset, but in this case, I'm going to build an analytic model and use that analytic model to perform the reporting. Okay, so here in this case, I go to the modeler section, create a new import model, start with the data only because I have the data already there. So what's your source? My source is a data set. I'm going for classic account model. I think data set is possible only in classic account model. So I'll go with source as a data set. So here I pick this option, guys. Go to new model. I told you, right? We have two options. Start with data, start with an empty model. If you have mass data, in place we go for empty model. If you have only transaction data from files or data sets, we go with start with data. So here also you have two things. New model type, start with data and start with an empty model. Classic account model, start with data and start with an empty model. I'm going for start with classic account model, start with the data. Choose my source as a data set. Means your data set will act as a source here. I'll take predicted data set as a source. Okay, here I can create a new calculation that is like premium paid something. I'll create like premium paid, which is nothing but monthly premium multiplied by month since policy inception. Create a new calculation that is also I'll take like something like premium per year, which is like monthly premium multiplied by 12. AC, I created two more measures, premium per year and monthly premium. So let's say create your data model. Right. So I have this model ready. Now I'll use this to build a story. Let's go build a story now. Okay, I go with canvas page, classic design experience. So I go for predicted claim amount and premium per year in the vertical direction. Edit story. I'll go edit my story preferences first. Chats and Gmails. Change my default palette. Let's add all borders. Tables also. Apply this to all pages and lines. Save. So you can see like claim versus premium. Let's save this story up. Yes, just a moment, please. Okay, so this is your overall predicted claim amount versus premium paid. I'll go create a new grid page, guys. Rename it as claim details. Insert a table. Check monthly premium. On since last claim happened. Predicted claim amount. Total premium paid and premium per year. Okay, in the dimensions, I'll pick customer ID, customer gender, location code of the customer, marital status of the customer, employment status of the customer, coverage, policy type, number of policies the customer has, vehicle class and vehicle size. I give all the details of the customer. I'll go here, 1500 rows and 20 columns. Okay, now you see all the data here. So you see all the customers, and here I can go. Fine. So guys, I would like to see the claim ratios also. Guys, I would like to see. Let's say insert a new chart. So I would like to see here you see. So objectives of my smart predict scenario are understand the claim amount per customer which is expected to come. So here you see in the claim details tab, you see all the customers and their predicted claim amount. So this number, the claims department can use this number, okay, to settle the claims. So that is done first thing. Okay, and they'll go for scrutiny if that number is quite higher than the predicted number. Then we also want to see uh, observe the claim amount pattern with respect to vehicle segment. So in this case, I also want to see. So how different factors impacting your claims. I'll use first model. Okay, I would like to see the number of first. I would like to do claim pattern with respect to vehicle segment. So I'll do that analysis first. So go for pie chart. I'll add the measures. How many customers we have in different uh, vehicle segments. So I would like to see the number of customers. Here we see number of customers with respect to vehicle class. Okay. And then I would like to see the claim ratio in different vehicle segments. It's very simple. So here I'll just define something like claim ratio. I'll create a new measure. Which is nothing but your predicted claim amount by premium per year. Claim per premium gives you this. So claim ratio is around 0.4. So here I go for vehicle class. So you see, here I can go draw a reference line which are above the average, which are below the average. Add a reference line 0.4. Above that is red, below that is green. You see, 4-door cars and 2-door cars are below that. The SUV is matching. Luxury SUV, luxury cars has a high claim ratios. And sports car, the luxury segment has high claim ratio when compared to the normal segment. So means ideally your organization should focus on the vehicles like normal vehicles like two-door cars, SUVs, and four-door cars instead of focusing on the luxury segment. So then this is, we also did this. We understand the claim amount per customer which is expected to come. Observe the claim amount pattern with respect to vehicle segment. This is also we did. Okay, now let's show how different factors influence your claim amounts. I would like to see how location could influence your claim amount. In this case, I insert a new chart. I'll go for combination column and line chart. Here I would like to see in the column axis the claim ratio and in the line axis predicted claim amount, and in the dimensions I'll go for location code. Don't overlap. So here you see, guys, in suburban region the claim ratio is 0.5, very high. In urban it's 0.3 and in rural it's 0.1. So your organization should more focus on the rural customers compared to suburban and urban regions. So again, I'll say insert a new chart. How monthly premium is impacting your claim ratio. But how, second is monthly premium, right? Monthly premium is a measure we need to convert into a dimension. So I go to dimension, create a calculated dimension. I'll create a measure based dimension. So here I go, monthly premium. Generally monthly premium is almost 60 to 100, guys. 60 to 200, I can show you the data. Starts from 61, goes to 286, but there are very few records above 150. Below 150 there are heavy. So in this case I'll go like, I'll put this way, 60 to 75. That is one range. 75 to 100 is another range. 100 to 150 is one range. Greater than or equal to, greater than 150 is another range. So I say greater than or equal to 60, less than 76. Here it is, greater than or equal to 76, less than 101, and equal to 101, less than 151. Okay, and this one aggregated customer level. So I say okay, I need a measure, that is claim ratio. In the line axis, I would like to see the number of customers in different segments, number of customers, and Okay, claim ratio indifferent. So greater than 150, the claim ratio is also high. It's not about the predicted claim ratio is also quite high. So they should focus on the customers with 76 to 100 and 0 to 65. So with less than $100 monthly premium, right? So there the claim ratios are on the lower side. Okay, so that is one thing we can see. So how monthly premium is impacting your predicted claims. Okay, so then I would like to see how different other factors also impacting. So in this case, I'll insert a new chat. Okay, I'll go for same combination column and line chart. In the column axis, I would like to see the claim ratio. In the line axis, I would like to see the predicted claim amount. Okay. In the dimensions, I'll go for dimension input control. What other factors impacting employment status, marital status, and vehicle size? Employment status, marital status. I take policy type also and vehicle size. If you want to see the state, I'll take state also. I'll take coverage also. How other factors impacting. So, okay. Don't overlap. See how employment status impacting. As in unemployed, the claim ratio is quite high, whereas in employed it's quite low. So you should focus on the customers who are more employed. The marital status also easy. In singles, the claim ratio is quite high when compared to married. Policy type also easy. Okay, corporate policy has high claims, whereas special policy has low claims. Vehicle size. See, in small size, the claim ratio is quite high. Whereas in large and mid size is quite low. So you should focus on the vehicles which are large and mid size. So this gives claims department. So where should they focus in reducing the claims or claim ratio? It should be the claim ratio because it's not the amount, claim ratio. The claim to the premium. Okay, makes sense. Right, so this is how different factor claim analysis, and I did a beautiful dashboard on claim details. So this will help the claim department in understanding their entire claim process, where they're paying more, where they're paying less, where should they focus to improve the profitability. Okay, so right now, I guess most of the large scale companies, right, they focus more on profitability rather than growing the sales. Right, this is how they do it. So we created an analytic model, predictive model on the predicted outcome, and we used that. We created a story on the predicted data set. Okay, which will help the claims department in understanding their claim settlement ratios. Okay, claim ratio is nothing but claim settlement ratio. Okay, so in which areas there is a high settlement ratios, in which areas they have low settlement ratios. Understand the claim amount per customer. Okay, so based on that, they can go for auto approval of the claims. Okay, and also check the customers who are making the false claims. Okay, makes sense. Any questions here, anyone? Land claim ratio also. So in the claim ratio, I'll sort highest to lowest. So now on top, you see the customers who are having the highest claim ratio, and you see most of them are unemployed. All the top customers are unemployed. So these are the customers who are at high risk of making false claims. Okay, they all are single, they all are unemployed. Right. So that is how we created one end-to-end classification predictive scenario, guys. We covered the regression predictive scenario. So maybe I stop here. In the next session, I'll go with time series forecast. Okay, I'll cover the time series forecast, and I also cover digital boardroom, guys. So I don't need the entire session to cover time series forecast. So I'll quickly cover the time series forecast, and then I'll go for digital boardroom also. So we'll wrap up this predictive analytics and digital boardroom by tomorrow, so that we can start on connections, a new topic from next week, connections, live connections and security administration in the next week. All okay. Thank you all. Have a great day. Thank you so much.